Welcome to all. I am Dr. B. Shekhar, working as an associate professor in Marri Laxman Reddy Institute of Technology and Management, Hyderabad. Today we will discuss about the one of the interesting topic. Nowadays, all the world is running towards the capacitors, supercapacitors, and the battery. So the battery related the basics introduction we will discuss here in the electrochemistry. Now I want to discuss about the electrochemistry today. The electrochemistry is one of the branch of the chemistry. Most it is relevant to the physical chemistry. The electrochemistry is a relevant to the physical chemistry. Electrochemistry is deals about the energy transformation. It is dealing the energy transformation of the energy is transferring from chemical energy to electrical energy and electrical energy to chemical energy, vice versa. These two, based on these two words, the entire the electrochemistry we are running towards the energy. How the energy is converting into chemical energy into electrical energy, and how the electrical energy is convert into the chemical energy. To understand this, the one of the electrochemical cell or galvanic cell. The electrochemical cell or galvanic cell is one of the best example to understand the electrochemical cell. Before to go the electrochemical cell, we want to know some of the fundamental basics regarding to the electrochemistry. And that the first one is nothing but the electrode potential. What is the electrode potential? The tendency of a metal to lose the electrons or gain the electrons. In this, what will happen when the metal is lose the electrons and gain the electrons? They have the energy difference. The energy difference we called as a electrode potential. If this electrode potential we will took at constant conditions, standard conditions, we will say that is standard electrode potential. Like you need to maintain the 25 degrees centigrade and 1 atmospheric pressure. Like that, if you maintain that potential, we called as a standard electrode potential. When we are talking about the standard electrode potential, here the two possibilities are there. One is loss of electron, another one is accepting of the electrons. The loss of the electrons we will called as a oxidation. The losing of the electron we called as a oxidation, and the acceptance of the electrons we called as a reduction. So the oxidation reduction we will explain with the help of these two simple reactions. Here you can see when a metal is placed in a solution containing its own ions, then the metal may undergo either in oxidation or reduction. If the metal undergoes in oxidation, if metal is undergo oxidation, we are getting metal positive ions and the free form of the electrons. These electrons they are moving towards the cathode in a cell or a battery. If the metal undergoes in reduction, then the negative ions may get deposit over the metal to show that we are getting it is a pure form of metal, we are getting it cathode. It is about the little bit introduction about the basics fundamentals of the electrochemistry. Along with this data, if you know the electrochemical series, the electrochemical series will help us to understand the batteries and to construct any cell array battery. Actually, what is mean by the electrochemical series? The electrochemical series is a series. The electrodes or metals, they are arranged in a order. That means if you see this diagram, in this the electrodes are the metals. They are arranged based on their reducing potential values. Based on these reducing potential values, here SH is standard hydrogen electrode we took. The standard hydrogen electrode value is potential value is 0. Based on the standard electrode potential, some of the electrodes they are arranged in the above the series and some of the electrodes or metals they are arranged in the below the series. In this, if you see in this top electrode is fluorine and the bottom electrode is lithium. In this, they have these all are negative potential and these all are have the positive potential. Which have the high reducing power, they easily undergo in oxidation and they release the electrons. So based on this electrochemical series, what we are concluding, based on which they have the less electrode potential, they easily undergoing in oxidation and they are releasing the electrons, and remaining they are acting as a cathodes and they are undergoing in reduction. This information we are getting from the electrochemical series. Based on this data, now we will understand about the one of the topic, that is electrochemical cell or galvanic cell. Already we are seeing what is meant by the electrochemical cell or galvanic cell. A cell which convert the chemical energy into electrical energy or vice versa. To understand the electrochemical cell or the Daniell cell, it is one of the best pictorial diagram to understand about the Daniell cell or galvanic cell. In this galvanic cell or Daniell cell, what we are doing, we are taking one anode and cathode. This anode and cathode we are deciding based on the electrochemical series. Already we are discussed that electrochemical series, it is giving information as to the increasing reduction potential values of the electrodes array metals. Based on the data, now we are constructing or here we are sketching a Daniell cell diagram. In this Daniell cell, what happening here, we are taking two half cells we are taking. Two half cells we are taking. One is anode half cell. One is anode half cell. This anode half cell also called as a oxidation half cell. The another half cell we call as a cathode half cell or reducing half cell. In this anode half cell, we are taking the zinc plate. We are taking the zinc plate. The zinc plate is immersed in a zinc sulfate solution. And we are taking the copper plate or copper electrode that is dipped in the copper sulfate solution. These zinc plate and copper plate, they are externally connected to the voltmeter to know the EMF value. When these two are connected with each other, these two half cells, they are connected with a salt bridge. Most of the cases, this salt bridge is filled with the KCl solution. It will helps us to balance the electron in both the half cells. Here, to easily understand which kind of reactions are undergoing, we will see here. In the Daniell cell, it is a representation of Daniell cell. It shows it is one half cell and this is another half cell. It is anode half cell and it is cathode half cell. This anode and cathode, it is a salt bridge. These two lines represent the salt bridge. At anode, the zinc is undergoing in oxidation. Zinc is undergoing oxidation. We are getting zinc plus ions, and along with we are getting the electrons. These liberated electrons, they are moving towards the cathode. They are moving towards the cathode. At cathode, these are deposited at cathode, and we are getting copper, pure metal we are getting. It is about the oxidation half cell. It is about the reduction half cell. If we will see the final reaction, if we will see about the final reaction, to easily understand, it is about the oxidation, it is about the reduction. If we cancel, which we have the both, now the remaining you can write, you are getting the overall reaction or final reaction. This zinc I wrote here, and this copper I wrote here. So my left hand side they are wrote here. Remaining what we have on the right hand side, you can see the Zn plus 2, the pure copper metal. This is about the final or net reaction. To understand these reactions and this diagram, this data will helps us. In this data, if you see here clearly, this cell is made of two half cell. Already we said one is oxidation or anodic cell, and the another one is reduction or cathodic half cell. It has cathodes as positive electrodes and anode as negative electrode. Already we are shown here, it is negative and it is positively already we are mentioned here. The first half cell consists of zinc electrode, act as a anode, and it is dipped in a zinc sulfate solution. And the second half cell consists of copper electrode or copper analyte, is dipped in a copper sulfate solution or analyte. Both the half cells, they are connected externally by a metallic conductor like voltmeter. The two electrolyte solutions are separated internally by a salt bridge. Already we have said the salt bridge will helps us to the flow of electrons. The solution can flow through and to touch each other. It provides electrical contact between two solutions and elimination of the liquid junction potential. They are separatedly each other, they will not touch each other. The movement of electrons in the electrochemical cell or Daniel cell, the movement of electrons from zinc to copper. In this reaction you can see the zinc is liberating the electrons are depositing at cathode. So the electrons movement is in from zinc to copper, means anode to cathode, produce a current in the circuit. That is the reason the electron flow is responsible for the flow of electricity in that circuit. It is a again representation of the Daniel cell or electrochemical cell. It is about the electrochemical cell or a Daniel cell or galvanic cell. I hope you understand this topic. The next session we will continue in next. Thank you.